Hello everyone. In this video, let's learn about electrode potential and cell potential. Now, what is electrode potential? The electrical potential difference set up between metal and its ion in the solution. So this is with reference to the voltaic cell which we learned in the previous video. That is, when you drop a metal in its ions or in the solution of its own ions, there is a movement of electron. There is loss or gain of electron which is taking place at the electrode. This loss or gain of electron is referred to as electrical potential difference, meaning the tendency of an electrode to lose or gain the electron when it is in contact with solution of its own ion, zinc in zinc sulfate, copper in copper sulfate, okay, is called electrode potential. Electrode potential is of two types. One is oxidation potential. Now, if the process that is taking place at any particular electrode is oxidation, then the potential developed at that electrode will be called oxidation potential. Electrode potential is termed as oxidation potential if oxidation takes place at the electrode with respect to any other reference electrode. So basically this means that you need to construct a cell and the reaction that takes place at the anode, the potential difference created by the electrode which is acting as the anode, that electrode potential will be oxidation potential. That means again, in the case of Daniel cell, zinc is at the anode. Zinc loses 2 electrons to form Zn2 plus. This is a spontaneous process. During this process, the process is oxidation and the potential here is called oxidation potential. Similarly, another type of potential, electrode potential, is reduction potential. Now, the reduction potential is electrode potential at the cathode or at the terminal where there is reduction. Okay, electrode potential is termed as reduction potential if reduction takes place at the electrode with respect to any reference electrode. With respect to any reference electrode, if there is reduction taking place, then that is called reduction potential. Example, in Daniel cell, at the cathode, Cu2 plus ions were taking up electrons to form Cu. In other words, the electrode was gaining electrons. Electrode was gaining electron. So at copper electrode, the process is reduction, and the potential is called reduction potential. Now, electrode potential depends on three factors: nature of the metal or the ion, concentration of ions in the solution, and also the temperature. Moving on to standard electrode potential. Now, the same electrode potential, if it is measured, calculated at 298 Kelvin and in 1 molar solution, 298 Kelvin, and the electrolyte is 1 molar solution, then the potential difference that you calculate is called standard electrode potential. Now, let's calculate what is EMF of a cell or cell potential. Fine. So, cell potential, which can be written as E of the cell, this is equal to the potential at the anode. But this is now the oxidation potential plus the potential at the cathode, which is again the reduction potential. But we cannot express the potential in terms of oxidation potential as per IUPAC. The potential, the electrode potential has to be expressed in reduction potential only. So, oxidation potential with its sign reversed. I repeat, oxidation potential with its sign reversed is called reduction potential, which means the above representation now is minus E of anode in terms of reduction potential plus E of cathode, which is any which ways reduction potential. Okay, that means EMF of the cell is equal to E of cathode minus E of anode, both expressed in reduction potential. So you can even remember this as E of the cell is E right minus E left. That means E of the right side electrode minus E of the left side electrode. This is better to remember. E of cell is E of cathode minus E of anode. But in this way also you can represent EMF of the cell. Now, if the same thing is measured with a 1 molar solution and at 298 Kelvin, then E of the cell can be written as E naught of the cell, that is standard electrode potential. Fine. So E naught of the cell will be equal to E naught at the cathode minus E naught of the anode. All right. Now, one additional information regarding electrode potential is, or standard electrode potential is, if there is any gas involved, the standard condition will be 1 atmospheric pressure instead of 1 molar solution. Standard condition will be 1 atmospheric pressure at 298 Kelvin. That's all regarding electrode potential and cell potential. Thank you for watching.